Good morning, everybody. Hope you're all healthy and fine at home. So let us continue with our chapter 5 about spectrum and Fredholm theory of compact operators. So in today's lecture, what we are going to discuss is we are going to actually try to find an answer to a question. Now, what was the question? The question is, when does the equation t of x minus lambda of x equal to y has a solution? Okay. When does this particular equation has a solution? This is what is a question that comes in our mind. That is, we are often discussing till now. We were discussing about t lambda and various properties of t lambda and its corresponding kernel and so on. So when does this have a solution? So let us just discuss about it. So for finding the corresponding solution of this particular equation, we are going to consider the dual of that particular equation. So what will be the dual? If we are having the operator t, then the corresponding dual will be t star, and instead of x I am going to take f, a function, and instead of lambda I am going to choose lambda bar. So consider the corresponding dual equation, and one more thing that we have to keep in mind, that is we are considering the homogeneous equation. Okay, homogeneous means, I guess you guys must be familiar with this, that is equal to 0. Okay, the equation will be equal to 0. Consider the corresponding dual homogeneous equation t star f minus lambda bar f equal to 0. Okay, consider this particular homogeneous equation, not solution, equation. Okay, now t star f minus lambda bar f equal to 0, or I can write this as, this is nothing but t lambda bar star of f equal to 0, right? So if t lambda bar star of f is equal to 0, I can say that this f is an element of kernel of t lambda bar star, right? Okay, so keep this in mind, f is an element of kernel of t lambda bar star. Now we are asked to find the solution or find the condition whenever this solution exists, that is t of x minus lambda of x equal to y, right? So this implies t lambda of x is equal to y, right? Or I can say that y is actually an element of image of t lambda, right? Image of t lambda, or this is equal to del lambda. So y is an element of del lambda and f is an element of kernel of t lambda bar star. Now we have seen in the proposition that we have discussed earlier that del lambda was nothing but it was equal to kernel of t lambda bar star. So in using this proposition, we can find a relation between actually the value of y and the corresponding elements, corresponding solution of the homogeneous dual. That is, we can find a solution. Okay, keep this proposition in mind, a solution x of the equation t lambda x equal to y exists if and only if fi of y should be equal to 0, where I is equal to 1, 2, 3, etc. up to k. That is, if you are considering set of solutions of the, that is, if f1, f2, etc., fk are the set of solutions of the homogeneous equation. See, actually it is very much easier to solve homogeneous equation rather than a non-homogeneous equation. So we can find the solution of the homogeneous equation that we had considered, and the solution of the equation exists if this corresponding to this set of solution fi of y is equal to 0 for every I. Okay, So then we can say that if this condition is satisfied corresponding to the dual homogeneous equation, then we can say that the given equation will definitely have a corresponding solution. We can easily find once we know the value of y, right, because fi and y are related because they are both are equal. There will be a corresponding relation between them. So if we can find the value of y, then we can find the value of x corresponding to this condition, right? So this is how we can find the solution of the problem that we were discussing, that is, when does the equation t lambda of x, t of x, or t lambda of x or t of x minus lambda of x equal to y will have a solution. So this was a very short lecture. You just have to use the proposition, and it can be considered when we consider the dual of the particular equation, and one more thing, the dual homogeneous equation, because we can easily find the solution for homogeneous equations. So that's it. Thank you all.